Hello friend, welcome to this lecture. In this lecture we will continue our study of linear system, and if you recall in previous few lectures we have discussed the solution process of finding solutions of the homogeneous linear differential equation. You can understand like this, that in previous few classes we have discussed x dash equal to ATX, how to find out a solution of this, and x dash equal to a of x. So, first we have discussed the existence and uniqueness criteria, and then we have say found the solution method to find out the fundamental matrix of solution of these two system. So, in this this is corresponding to autonomous system, where this matrix A is not depending on time t, then we call this system as a autonomous system, while this system is called non-autonomous system. And in the case when A is having n linearly independent eigenvectors, then we know how to find out a solution, and we have found the solution xi t equal to e to power lambda I t vi, where lambda I vi are eigenpair of the matrix A. And when we are not we are not able to find out n linearly independent eigenvectors, then we have seen the process of finding the solution of the form e to power a t into v, and based on the type of v, we have found the solution using this concept. And we have seen that how to calculate the fundamental matrix solution x t, where x t is nothing but x 1 t to x n t, where each x I is a solution of x dash equal to a x. And also for non-autonomous system also we have discussed certain method to find out the solution of this, and we have also seen that in general this e to power t naught to t as ds will not work as a fundamental matrix of solution here. So, here we have seen that under certain conditions, as that a t and this matrix, if they commute, then we can consider this as a say possible form of a solution of x dash equal to ATX. And we have seen certain other type of solution of x dash equal to ATX. Now, we will proceed further, and now we will focus on non-homogeneous system of linear equation. So, now consider the following linear non-homogeneous differential equation x dash equal to ATX plus ft. So, the only thing different from this to previous thing, that here now we have one more term extra, that is f of t, which is known as force term, or say external force term, we can consider that. So, if we have this system x dash equal to ATX plus ft, then we call this system as linear non-homogeneous differential equation, and we try to find out a solution of the problem with the help of a fundamental set of solution of the associated linear homogeneous differential equation. So, to find out the solution of this, we consider the associated homogeneous linear system, that is x dash equal to ATX, and then we know the fundamental matrix solution is already available, that is x 1 t to x n t. So, once we have the fundamental matrix solution for homogeneous part, then we try to find out the solution to for this linear non-homogeneous differential equation. Okay. So, we now so far we have discussed some method to find out a solution of a given linear homogeneous differential equation of the following type, that is x dash equal to ATX. Now, we may use the variation of parameter method to find the solution of the initial value problem x dash equal to ATX plus ft and x t naught equal to x naught. So, what is variation of parameter method? If you recall, the solution, general solution of x dash t equal to Ax is written as x of t equal to x of t into matrix C, where C is, or you can simply write it like C1 x1 t plus C2 x2 t plus xn t Cn xn t. Now, here if you look at C1, C2 and Cn are all constant. Now, if we consider if we vary or we can say that you can take any arbitrary value of these constant and still it will serve as a solution. Now, I can say that if C1, C2 and Cn are variable constant, or you can say that the parameters, then this will act will act as a solution of, under certain condition, this will act as a solution of the non-homogeneous problem. So, it means that we are varying our parameters such that this will serve as a solution of non-homogeneous problem. We will try to understand what is what I mean through this. So, here let us assume that x1t to xnt forms a fundamental set of n solution. Fundamental set of n solution means that all these are linearly independent and they are solving the solution system x dash equal to ATX, right. So, they are solution as well as they are linearly independent. Then the general solution of 1 is given as XH. XH here means homogeneous part. So, the solution of homogeneous linear equation is given as C1 x1t plus C2 x2 plus Cn xn t here, where Ci I from 1 to n are n real constant. Now, therefore, we may assume that a solution of 2, that is x dash equal to AT x plus Ft, we may assume that it will take the form xt equal to u1 x1t plus u2 x2t plus un xn t here, where ui are n parameters. So, if you look at what is the difference between here and here, if you look at here, these C1 to Cn's are constant, but here your u1 to un are parameters. So, we are basically varying these parameters so that this term 3 will act as a solution of the non-homogeneous problem x dash equal to ATX plus Ft. So, just look at how this will work. So, we may rewrite the above equation in the following matrix form, that is x of nh equal to xh into ut, where nh is the solution of non-homogeneous problem, xht is the solution matrix, or we can say fundamental matrix solution given by this matrix x1t to xnt. We are calling it fundamental because x1 to xn are given n linearly independent solution of x dash equal to ATX. So, it means that we are writing our solution of non-homogeneous problem as xht into ut. Now, we need to find out the matrix ut, where ut is given as u1t to unt. This is a column matrix, where each component of column matrix u1t to unt are some unknown function which we need to determine, so that this will act as a solution of non-homogeneous problem. So, now using the expression of xht in the differential equation x dash equal to ATX plus Ft, and integrating between t naught to t, we have the following formula. Let us try to understand that how we got this formula for here. So, please look at here, the solutions is this part. Let me look at here. So, here we have x dash equal to ATX and we have solutions x1t to say xnt here. So, here we have x1t to xnt. So, with the help of these n linearly independent solution, we form matrix like x1t to xnt, right. So, it means that this will satisfy the following matrix differential equation x dash t equal to AT x of t here. So, here it is n cross n, here it is n cross n, here it is n cross n. Now, we claim that this x nh is equal to xt and ut, where ut is equal to u1t to unt. These are some n function which we need to find out, and this is known as x of h. Now, let us try to find out this ut such that this will act as a solution of x dash equal to ATX plus f of t here. Please note down, this is n cross 1, this is n cross n, this is n cross 1 and this is n cross 1. So, let us verify here. So, when we if it is a solution of this, it will satisfy this. So, it means that let us find out x n h dash equal to x dash t and ut plus x of t u dash t, and we want that it should be equal to your a t x, x is here as x of t and u of t plus f of t. So, it means that we need to find out this u t in a way such that x dash n h, which is coming out to be this, must be equal to this. Now, since x dash t here it is x of h, here x h of h. So, here this x h is a matrix solution of this matrix equation, that is x dash t equal to a t x t. So, using this we can write it this as a t x of h t u t plus x of h t u dash t equal to a t x s t u t plus f of t. Now, if you look at this, these two are equal. So, we can cancel out here, and what is left here is x t x s t u dash t equal to f of t, but we are interested in finding this u t. So, we can take the, since x h t is basically a fundamental matrix solution. So, inverse exists. So, we multiply by the inverse of this, and we can write here as x inverse h t u dash t equal to sorry, x t is here x s t. Let me write it in a clear manner. So, we can multiply by the inverse of this, and we can have this x h t inverse of f of t, but since it is u dash t. So, let us integrate to find out u t. So, let us integrate between t naught to t, where t naught is the initial point and t is some point lying in some interval. So, this will, when we integrate, we have u t equal u t minus u t naught equal to t naught to t x inverse s f of s d of s, right. So, we need to find out u t. So, u t is basically u t naught plus t naught to t x 1 x h inverse s f of s d of s. So, now u t is known to us, but so with the help of u t, now we can find out the solution of non-homogeneous problem, that is x of t into u t. So, this I can write it x of t u t naught plus t naught to t x of t x inverse, this is x h, this x h. So, x h t into x inverse s f of s d of s. So, this is the solution of non-homogeneous problem, that is x s t u t naught plus t naught to t x s t x inverse h s f of s d s. The only problem is that what is the value of u t naught. So, if you look at, I can use this equation to find out the value of u t naught. You can find out x of n h at t naught equal to x h t naught u t naught. So, we can multiply by the inverse of x t naught, since x is a fundamental matrix solution. So, inverse exists for all t. So, in particular for t naught also. So, I can find out the value of x t naught equal to x h inverse t naught into x n h t naught. So, and we have so if this okay. So, we can write this and we can have our solution like this. So, x n h x n h t equal to x h t. Now, x inverse t naught and x n h t naught plus t naught to t x h inverse t x, sorry, this is not inverse, it is x h t and x h inverse s f of s d of s. So, now it is written completely, and so this will act as a this is already known to us, that x of n h t naught is known to us, it is already given with the initial value problem. So, this is known to us, and if we are able to find out x h of t, then we can calculate x h inverse of t also, and we can calculate x h of t naught also. So, all these are calculable when x h t is known to us. I can say that using the expression of x h t in the differential equation x dash equal to a t x plus f t, and integrating between t naught to t, we have the following formula: x n h t equal to x h t x inverse h t naught x naught, where x naught is basically x n h at t naught. If you look at here, it is already given here that x of t naught equal to x naught. So, using this I can write this x n h t naught as x naught plus x h t, since it is this integration is with respect to x. So, I can take it out x h t, and we can write t naught t x h inverse as f of s d of s. So, this is the when x fundamental matrix solution of this system x dash equal to a t x is known to us, then we can write down the solution, one particular solution of x dash equal to a t x plus f of t, and it is given by equation number 4. Now, since for autonomous case we know one fundamental matrix solution given by e to power a t. So, e to power a t may be taken as a fundamental matrix solution. Then this equation number 4 may be written in this following manner: x of t equal to e to power a t minus t naught. This expression is I am using for x h t x h inverse t naught. If you look at, if x of t is equal to e to power a t, then x inverse of t, you can verify that it is nothing but e to power minus a t, that you can verify that x t into x inverse t equal to e to power a t and e to power minus a t. Now, since these two matrices commute to with each other, so we can write this as x of t x inverse t is equal to e to power a t minus a t, that is e to power 0, this is nothing but identity. So, this will act as a inverse matrix of this x t equal to e to power a t. So, once we know the inverse, then we can calculate x t into x inverse t naught, that is nothing but e to power a t into e to power minus a t naught, and we can simply write e to power a t minus t naught. Similarly, we can calculate x of t x inverse of s, this is nothing but e to power a t e to power minus a of s, that is e to power a t minus s, that is what it is written here. So, I can say that your solution of non-homogeneous differential equation is given as x t equal to e to power a t minus t naught x naught plus t naught to t e to power a t minus s f of s d of s. So, it means that so we need to find out e to power a t for the homogeneous part, then we can write down the solution of non-homogeneous part using the equation number 5. Now, once we have the formula with us, let us see some example and see how we can calculate this. So, let us consider the first example. Solve the following linear non-homogeneous initial value problem: x dash equal to 1 0 0 2 1 minus 2 3 2 1 x plus 0 0 e to power t cos of 2 t, with the initial condition that x of 0 equal to 0 1 1. So, I can write this as a system x dash equal to a of x plus f of t, where a is the matrix given like this 1 0 0 2 1 minus 2 3 2 1, and f of t I am writing this as 0 0 e to power t cos of 2 t. Okay. So, now we need to calculate the fundamental matrix e to power a t. So, for that since it is a constant matrix, let us find out e to power a t with the help of fundamental matrix of solution. So, for that we need to find out 3 linearly independent solution of x dash equal to a x. So, for that let us first find out the eigenvalues of the coefficient matrix A. So, for that consider the characteristic equation of A, that is determinant of A minus lambda I equal to 0, that is 1 minus lambda 0 0, 2 into 1 minus lambda minus 2, 3 to 1 minus lambda equal to 0. When you simplify, you will have the following expression, that is 1 minus lambda into 1 minus lambda whole square plus 4 equal to 0. So, this will give you a simple root, that is lambda 1 equal to 1, and if you simplify this, this is what 1 minus lambda whole is square minus 4, but this is possible when lambda take the value complex value. So, 1 minus lambda equal to plus minus 2i. So, lambda is equal to 1 plus minus 2i. So, we call this as lambda 2 comma 3, that is 1 plus minus 2i here. So, so if you look at lambda 1 equal to 1, lambda 2 equal to 1 plus 2i, and lambda 3 equal to 1 minus 2i. So, if you look at all three are distinct. So, it means that if we all three are distinct, so it means that we have guarantee of having 3 linearly independent eigenvectors in this case, and we can find out 3 linearly independent solutions. Okay, and hence we can find out a fundamental matrix solution in a quite easy manner. And so, first find out the eigenvector corresponding to lambda 1 equal to 1. So, for that we need to solve this a minus lambda 1 I into this x equal to 0 here. So, here let us put lambda 1 equal to 1 and try to solve here, where x is given as x1, y1 and z1. So, it is the following equation: 1 minus 1 0 0, 2 1 minus 1 minus 2 3 2 1 minus 1 x1 y1 z1 equal to 0 0 0. So, if you look at the first equation is nothing but 0 0 0. So, it will not give any equation in terms of x1 y1 z1. If you look at the second equation, it is 2 x1 minus 2 z1 equal to 0, and 3 x1 plus 2 x2 equal to 0. So, if you look at here, we can easily find out your x1 as z1, and with the help of x1 you can put it here, and you can write it here 3 z1 plus 2 x2 equal to 0. So, it means that x2 is given as minus 3 by 2 x of 2 z1 here, sorry, it is some problem here, it is x y1, it is basically it is y1 here. So, it is 3 x1 plus 2 y1 and it is y1. So, we can write it y1 equal to minus 3 by 2 x1 3 by 2 z1. So, now x1 can be written as z1 and y1 can be written minus 3 by 2 z1. So, we can take some suitable value for z1. So, let us take value z1 equal to 2, then I can write y1 as minus 3 by 2 into 2, that is minus 3 here, and your x1 is nothing but z1. So, eigenvector is coming out to be x1, that is 2, y1 that is minus 3 and z1 is 2. So, 2 minus 3 2 will be the corresponding eigenvector, and so we can find out linearly independent solution corresponding to lambda 1 equal to 1 as e to power lambda 1 t v1. So, e to power lambda 1 is 1. So, e to power t 2 minus 3 2 is one linearly independent solution. So, x1 t equal to e to power t 2 minus 3 2 is basically a linearly independent solution of this. Now, second thing is find out the eigenvector corresponding to lambda 2 equal to 1 plus minus 2i, and we have already discussed this case, that when we have complex eigenvector case, then we have eigenpairs, eigenvectors, eigenvalues comes in pairs and eigenvector also comes in pairs. So, here we know that how to find out two solution out of this. So, let us first find out the eigenvector corresponding to lambda 2 equal to 1 plus 2i. So, we simply solve a minus lambda 2i your x equal to 0 here. Here x, let us assume that it is x2, y2 and z2, we need to find out this x. So, let us put the value of lambda 2, that is 1 plus 2i. So, we have 1 minus 1 plus 2i 0 0 x2 y2 z2, and so we can have this. Now, when you simplify, then we have the following equation: minus 2i 0 0 and 2 here, minus 2i minus 2 3 2 minus 2i x2 y2 z2, and that is 0 0 0. So, one thing is very much clear here, that minus 2i x2 equal to 0 means that your x2 has to be 0. So, if you look at the second equation is 2 x2 minus 2 y2 minus 2 z2 equal to 0. Now, x2 is 0. So, this part is gone. So, we can write down 2 y2 equal to z2 minus z2. So, now I can put the value of y2 or z2 and we can find out the corresponding value of so x2 is 0. Now, put y2 as I. So, if you put x2 equal to 0 and y2 equal to I, then z2 you can find out as it is 2I into I equal to minus z2. So, this is 2I square, that is minus 2, and that minus will cancel out. So, z2 will come out to be I think there is something wrong here, it is 2 z2 here. Okay. So, z2 is coming out to be 1. So, your x2 y2 z2 is coming out to be 0, I and 1. So, solution, the complex solution will be given as xt equal to e to power 1 plus 2 I t 0 I 1, and when you solve, this is a complex valued solution, and if you solve the other way around, that is 1 minus 2 I, then also you can find out the eigenvector, just complex conjugate to this eigenvector, but and we will get a similar kind of solution for other one, that is 1 minus 2 I. So, first find out the real and imaginary part of this complex valued solution. So, we can write e to power 1 plus 2 I t 0 I 1 as e to power t cos 2 t plus I sin 2 t 0 0 1 plus I times 0 1 0, that we are writing as 0 I 1. So, here we are writing the real part different and imaginary part different. So, now we multiply here. So, first write down the real part, that is e to power 2 cos 2 t 0 0 1, that is this thing, and when you multiply these two term we will have negative part, that is sin 2 t 0 1 0. Similarly, we can find out the complex part, that is e to power t cos 2 t with 0 1 0, that is we are writing here, and then this with this. So, sin 2 t 0 0 1. So, sin 2 t 0 0 1, e to power t we are taking out. So, we can write down the imaginary and real part in this way. If you add this, what you will get, e to power t and 0, and it is minus sin 2 t cos 2 t, and here imaginary part is I e to power t, and then it is cos 2 t sin 2 t. So, here this is the real part and this is imaginary part, and we have already seen that real and imaginary part also forms linearly independent set of solutions. And this we have not proved, we have just proved that if x t equal to y t plus I z t is a complex solution, then y t and z t also a solution of x dash equal to a t x t. This we have proved, but we have not proved that y t and z t are linearly independent. In fact, you can prove in a easy manner. You simply just show that that y t and z t are solutions corresponding to say different distinct eigenvectors corresponding to distinct eigenvalues. So, this you try and we can prove that y t in general, that if x t equal to y t plus I z t is a complex valued solution, then y t and z t are two real valued linearly independent solution of x dash equal to a t x t, that you can verify. In fact, you can verify like this, that x t equal to y t plus I z t, then you can find out the x bar t as y t minus I z t. So, we can write down y t and z t in terms of x t and x bar t, and then you can show that this x t and x bar t are linearly independent. So, y t and z t are also linearly independent. You try. The crux of the matter is that now we are able to find out two new linearly independent solution, x 2 t equal to e to power t 0 cos 2 t 0 cos 2 t sin 2 t, and real part as x t equal to 0 sin 2 t minus cos 2 t, that is this thing. So, here we may observe this thing that x3t we have written, I have written as et 0 sin 2t minus cos 2t, but here it is just minus different. So, it is 0 minus sin 2t cos 2t, but in anyway if x3t is a solution, then minus of x3t is also a solution of x dash equal to atx. Okay, so with this we can say that x2 and x3 are two linearly independent solution of x dash equal to atx. So, now we can write down, we can check that x10 is 2 minus 3 2, x20 is 0 1 0, and x30 is 0 0 minus 1, and we can check easily that these three are linearly independent eigenvectors of R3. So, it means if these three are linearly independent eigenvectors of R3 and x1, x2 and x3 are three linearly independent three solutions of x dash equal to atx, then it will form three linearly independent solutions of x dash equal to atx, and we can write down the general solution of our initial value problem as this: xt equal to c1 e to power t 2 minus 3 2 plus c2 e to power t 0 cos 2t sin 2t plus c3 e to power t 0 sin 2t minus cos 2t. So, so general solution of homogeneous problem is written like this. Now, with the help of this we can form the fundamental matrix of solution, that is this is your x1t, this is x2, it is x3. So, we can write down the fundamental matrix solution of x dash equal to ax may be given as xt equal to 2 et minus 3 et 2 et 0 e to power t cos 2t e to power t sin 2t 0 e to power t sin 2t minus e to power t cos of 2t. And once your xt is given to us, and we have already checked that it is these three solutions are linearly independent solution. So, this xt is a invertible matrix, that is non-singular matrix. So, we can observe the value of x of 0, which is coming out 2 minus 3 2 0 1 0 0 0 minus 1, and we can check that determinant of x 0 is coming out to be non-zero, and hence we can find out the inverse of x of 0, that is 1 by 2 0 0 t by 2 1 0 1 0 minus 1. You can find out the inverse using your properties of matrix, and you can easily find out the inverse of x of 0, and it is given as x inverse 0. So, idea is to calculate e to power at, the fundamental matrix solution e to power at is now calculated as xt x 0 inverse. We are writing e to power t, x of t is already given to us, x inverse 0 we have just calculated. So, we multiply xt and x 0 inverse, and we have the following solution, following matrix as a fundamental matrix solution e to power at. So, now e to power at is given to us, then we can use our formula to find out the solution of non-homogeneous problem, that is x of t equal to e to power a t t minus t naught plus t naught to t e to power a t minus s f of s d of s. So, here e to power at is already known to us, t naught is coming out to be 0. So, we can write e to power at minus t naught as e to power at into this is x of t naught. So, x of t naught is 0 1 0 plus e to power at 0 to t e to power, now we are writing e to power minus as e to power at is given here, then e to power minus as is simply replace t by minus of s, and we can write down e to power minus of a of s, and we can write it like this. So, here you can check that it is actually written as e to power a minus s, and we can have this, and multiply by f of s, that is 0 0 e to power t cos of 2 s f s we are writing like here, and we can multiply this expression into e to power minus s. You can integrate with respect to 0 t and then multiply e to power at, and we simplify, and we can have this as a solution x t equal to e to power t 0 cos of 2 t minus 1 plus 1 by 2 sin 2 t and 1 plus 1 by 2 cos of 2 t plus 5 by 4 sin 2 t. And this process is quite lengthy and tiring. So, we can see that even though we are able to find out e to power at, but this calculation is quite lengthy, I will say. So, finding the solution of non-homogeneous problem using variation of parameter method is quite difficult. So, another alternative methods available to find out the solution of non-homogeneous linear system is the use of a nice guess. So, if you look at f of t is 0 0 e to power t cos of 2 t. So, it means that here you can say that this we can find out the possible way of solution is something like alpha times e to power t cos of 2 t plus beta times e to power t sin of 2 t, and then we trying to find out alpha beta in a suitable manner such that it will satisfy this non-homogeneous problem. This is something which you do for the scalar valued function. So, you can see that both are giving you the same result that is given here as this. So, now let us consider one more example so that this can be simplified in a better way. So, let us consider 2 by 2 matrix case where this can be further simplified. So, solve the following initial value problem: x dash equal to 1 0 0 2 x plus sin 80 cos bt, where initial condition is given as x of 0 is equal to 0 and 1 here. So, first thing to find out e to power 80, that fundamental matrix solution of x dash equal to ax, where a is given as 1 0 0 2. So, we have taken very simple case. If you look at this is nothing but diagonalizable case. So, we can find out the eigenvalues in a very easy manner, that is nothing but the diagonal entry of this matrix. So, lambda 1 equal to 1 and lambda 2 equal to 2 eigenvalue of matrix A. So, we can find out the eigenvector corresponding to lambda 1 equal to 1, that is coming out to be 1 0. So, we can simply write it here that y1 is coming out to be 0. So, x1 you can take any arbitrary value, in particular I am taking value as 1. So, we eigenvector corresponding to lambda 1 equal to 1 is 1 0. So, we can write down the first solution x1 t is equal to e to power t 1 0. Similarly, we can find out the eigenvector corresponding to lambda 2 equal to 2, and you can see that your x2 is coming out to be 0 here. So, y2 is you can take any arbitrary value, we have taken the particular value, that is 1. So, eigenvector corresponding to lambda 2 equal to 2 is given as 0 1. So, your x2t is given as e to power 2t and 0 and 1. So, x1t and x2t are coming out to be very easily, and we can write down the fundamental matrix solution as x1t is e t 0 and x2t is 0 e 2 t, right. So, that we have written here. So, this we can write e to power t 0, and this we can write it 0 e to power 2 t. So, with the help of x1t x2t we have written xt is e t 0 0 e to power 2 t, and we can write down x of 0 is nothing but 1 0 0 1. So, it is a identity matrix, so it is invertible. So, xt is a fundamental matrix solution. So, we can find out the inverse of this, and since it is identity matrix, inverse is coming out to be identity equal to. So, e to power 80 is nothing but the xt into x inverse 0. So, that is coming out to be xt itself. So, e to power 80 is coming out to be e to power t 0 0 e to power 2 t. So, now we can find out the inverse of this, and inverse of the this is nothing but, so e to power minus as you can write simply as e to power minus s 0 0 e to power minus 2s, right. Now, we can write down the formula here. Formula is this: xt e to power 80, initial condition x 0 is 0 1 plus e to power 80 0 1 0 t e to power minus s 0 e 0 e to power minus 2s sin as sin bs ds. This is as it is. Now, e to power 80 we have taken it out 0 t, if you multiply what you will get, it is nothing but e to power minus s sin of as, and this is nothing but e to power minus 2s cos of bs ds. So, we can integrate this is nothing but e to power 80 0 1 plus e to power 80 and 0 t, and now rather than we can take integration of this matrix is nothing but integration of each component. Now, you can find out the integration of e to power minus s sin of as and e to power minus 2s cos of bs, and it is coming out to be this, that e to power minus s divided by 1 plus a square minus sin as minus a cos of as. Similarly, we can find out 0 to t e to power minus 2s cos of bs as e to power minus 2s 4 plus b square minus 2 cos bs plus b sin 2s 0 to t. So, now we just plug in the limits here, and we can plug in the limits, and we can have like 0 to 0 e to t, that we have just calculated e to power a t into 0 1, that is coming out to be 0 e to t plus this is e to power a t into this we have plug in the value. So, here when we multiply and we have the following value e to power minus t 1 plus a square minus sin a t minus a cos to a t plus this thing, and in this we have plug in the limits of 0 to t, and when you simplify you have this solution. This is quite lengthy, I will say, though it is 2 by 2 case, but still it is quite lengthy. We say that though it is a very good method and you can find out the solution of almost all the problems, but it is quite lengthy. So, I suggest that you can also consider the solution system which involves the say guessing, say finding the undetermined coefficient, method of undetermined coefficient. You can try finding the solution of non-homogeneous linear system. So, with this I end this lecture. We will continue our study in next lecture. So, in this lecture we have discussed the solution of non-homogeneous linear differential equation with the help of solution of homogeneous linear differential equation, and we have used the method of variation of parameter method in this lecture. We and also observe that though this process is quite lengthy, but it is quite reliable, and you can find out the solution of almost all the linear non-homogeneous problem with the help of the present method which we have just presented. Other alternative methods available are method of undetermined coefficients and other method. So, with this we end our lecture. Thank you very much for listening this. Thank you.